Okay, we're now at example 1 in section 6.3 on exponential functions. We have seen the exponential function in general, how it is increasing when a is greater than 1 and decreasing when a is a number between 0 and 1. And now we'll look at some transformations. We're given a function, in this case f of x equals 2 to the x plus 1 minus 2, and we're to graph it using our transformations. We'll determine the domain, the range, the horizontal asymptote, graph, and label. So what is the parent function we're dealing with here? The parent function would be f of x equals 2 to the x, right? So what we're seeing in our transformation is inside the function being raising the power to x, we're adding 1. So inside the function means that's a horizontal impact, right? It means we're going to transform our y coordinates, and it's x plus 1. So this is a horizontal shift. Which direction? The horizontal shift, when it's plus 1, we're going left 1 unit. So that means we will subtract 1 from x. That will cause the graph to move left. Okay, making a little note to ourselves. The other transformation we see is outside of the function being the power, and it is a vertical shift. Which direction? Down 2, yes, down 2. So that means we will subtract 2 from all of our y values. Now, what are the points on our parent function? Recall, it's negative 1, 1 over a, negative 1, a is 2. Notice, let's make a note, a is 2. 1/2, that's on the original parent function. Of course, you can just plug these in and recalculate, but if we put in negative 1, we get 1/2. If you put in 0, what do you get? 0, 1. And if you put in 1, of course, you get 2, 1, and a. So we'll transform each of these and graph our new function. All right, for the x coordinates, let's just do all the x's, because all we're going to do is subtract 1. Negative 1 minus 1 is negative 2. 0 minus 1 is negative 1. 1 minus 1 is 0. Those are our new x coordinates. Now for the y's, we'll subtract 2. 1/2 minus 2 would give us negative 3/2. 1 minus 2 would give us negative 1, and 2 minus 2 would give us 0. So these points have been transformed here. So we have negative 2, negative 1.5, negative 1, and 0, 0. So our new exponential function looks something like this. Okay, notice that the original, of course, this point, the negative 1, was at the origin originally. Was at 0, 1 originally, here, right? So this point has gone left 1, from here, left 1, down 2. So originally at 0, 1, left 1, down 2, we're at negative 1, negative 1. The other 2 points have done the same thing. All right, so what is our domain? Oops, what is the domain of this function? Broke my lead. Let me get another pencil here. The domain is all real numbers, isn't it? Okay, so we'll write that in interval notation. Okay, and what is the range? All right, how low does it go? Will we ever cross this line, y equals negative 2? Let's mark this one. This is our horizontal asymptote, y equals negative 2. Will we ever touch it? Could we ever plug something into this so that this term would be 0 and we would just get f of x equals negative 2? No, there is no value for x that we can plug in that would cause this term to go to 0. So we get as low almost to y being negative 2, but never gets there. And then, of course, to positive infinity. And our asymptote, I'll just abbreviate here, is the equation y equals -2. We have dropped that. That shifting down to dropped our asymptote from the x-axis down to the horizontal line, y equals -2. All right, let's do another example quickly here. We have f of x equals -2 to the x. So again, our parent function is f of x just equals 2 to the x, right? So we only have one transformation. Is it inside the function or outside the function? It's outside, right? We don't need to raise that. We don't use that negative sign until after we raise 2 to the x. So the function stays as it is. So it's outside, which means it affects what? Horizontal or vertical? Outside means vertical. So we have a vertical what? What is the transformation that we see here? There's only one to go from this to this. Vertical reflection or flip. For fewer letters, I'll write flip. So if you have a vertical flip, which axis are you reflecting over? The x-axis, right? So we reflect, I'll write this, over, just to have this in your notes, x-axis as a reminder. And so what makes our points do that, right? So if I had just some random point here, 2, 2, if I want to flip it over the x-axis, it becomes 2, -2. So which variable changed, x or y? The y changed. And what changed about it? Its sign. To change the sign, we'll multiply y by -1. That's all we need to do. So again, our points are -1 and 1/2 because again, a is 2, 0, 1, and 1, 2. The only thing that's happening here is all the y values will change sign. So we have -1, -1/2. We have 0, -1, and we have 1, -2. -1, -1/2, 0, -1, and 1, -2. So we are here. So recall, the parent would have been skimming along like this, so we have reflected over. So what is our horizontal asymptote? That hasn't changed, has it? We didn't move vertically, so y equals 0 is still our horizontal asymptote. Domain, still all real numbers. The range, though, low to high, -infinity to almost to 0, but we never will get there, right? And of course, our asymptote is the x-axis, y equals 0.